Hello and welcome to another video on Pythagoras. Now in the previous two videos we looked at using Pythagoras' theorem to calculate the hypotenuse in a right angled triangle and also one of the shorter sides in a right angled triangle. So in this video we're going to put all of that together and we're going to take a look at some problem solving type questions. So I've got 12 questions for you to have a go at. I always encourage you to do the questions first, see how you get on, and then if you do get stuck, you can have a look at my workings out. So I've got 4 questions on each page. So pause the video and see if you can have a go at these 4 questions, and then we'll go through the answers, and then we'll do the next 4 and then the next 4. So question 1, a 9-meter ladder is placed against a wall, which we can see over here. The foot of the ladder is 1.5 meters from the foot of the wall, so that's this distance here. How far up the wall does the ladder reach? So we need to calculate this distance here, which is x. So first of all, we're assuming that this wall is straight, so it's built, perpendicular to the ground. So that means that this is a right angle. So now we've created a right angle triangle, we can use Pythagoras to calculate this missing side length. So let's just remind ourselves again what Pythagoras' theorem states. Is that if we square each of the shorter side lengths and add them together, that will give us the hypotenuse squared. So if we just write out an equation, so if we square this value, so x squared, and then we add on this value squared, so 1.5 squared, well, that will give us the hypotenuse squared. That will give us 9 squared. So let's just work out what these are first. So we've got x squared plus 1.5 squared. Well, 1.5 squared is 2.25, and that is going to equal 9 squared, which is 81. So now to get this x squared on its own, we just need to subtract 2.25 from both sides. So we're going to be left with x squared is equal to 81 minus 2.25, which gives me 78.75. 78.75. And now to work out what x is, we just need to take the square root. So x is going to equal the square root of 78.75. And I will need my calculator for that. And remember, usually when you take the square root, you get 2 answers. You get a positive and a negative. But because we're dealing with distances, we only need to take the positive value. And that gives me 8.87. 8.87. It doesn't say in the question what to round to, so I'm just going to round to 2 decimal places. But we do need our units, so you can see we're dealing in meters here. So 8.87 meters is our answer. Question 2. Shown is a square with side length 5 centimeters. Find the length of the diagonal x. So the key thing here is that this is a square. So as this is a square, each of these side lengths is 5. So I'm going to write in 5 centimeters here. We don't need to write in these 2. So now you can see we do have a right angle here. So we've got a right angle triangle. Both of the shorter side lengths are 5. So we can work out the hypotenuse using Pythagoras' theorem again. So it's going to be 5 squared plus 5 squared. So we square each of the shorter side lengths and add them together. That is going to give us our hypotenuse squared. So that's going to equal x squared. So 5 squared is 25, so it's going to be 25 plus 25 is equal to x squared, and then that's clearly 50. So 50 is equal to x squared, and then the final thing is just to take the square root. So x is going to be equal to the square root of 50, and again I need to put that into my calculator. Square root of 50, I know it's just going to be just above 7, because I know 7 squared is 49. But let's get a slightly more accurate answer. 7.07. 7.07. And this time our units are in centimeters. Question 3. Shown is a right angle triangle. Calculate A, the perimeter of the triangle, and B, the area of the triangle. Well, to calculate the perimeter, we need to know this value here, x. So first of all, let's use Pythagoras' theorem again. So it's going to be x squared plus 7 squared, and that is going to equal 25 squared. So let's just evaluate each of these numbers here. 25 squared, I need to remember to include that. So it's going to be x squared plus 49, and 25 squared, I think that's 625, but let me just check. Yep, 625. Okay, and now let's subtract 49 from both sides. So we'll be left with x squared is equal to 625 minus 49. That's 576. So then x is going to be equal to the square root of 576. So let's put that into the calculator. And that's quite nice because we get an integer answer. That is 24. So 24 centimeters is x. So I'm just going to rub out this now and just put in 24 centimeters. So we still haven't finished part A. The perimeter, well, we just need to add up all of these. So it's going to be 25 plus 24 plus 7. I don't need a calculator for this. 25 plus 24 is 49, plus 6 is 56. So 56 centimeters. Oh, let me just make that clearer. 56 centimeters is my answer for part A. And now moving on to part B, the area of the triangle. Well, to calculate the area of any triangle or any sort of right angle triangle, we would do half base times height. So this is going to be a half times the base, which is 24, times the perpendicular height, which is 7. So let's work this out. Well, half of 24 is 12, and 12 times 7 is 84. So it's 84, and our units are going to be centimeters squared. Question 4. A rectangle is 20 centimeters long and 8 centimeters wide. Find the length of the diagonal of the rectangle. So this time we're not given a diagram, but we could just do a sketch. So again, obviously this isn't to scale and I'm not using a ruler, so please forgive me for this. So 20 centimeters is the length and 8 centimeters is the width. So we need to calculate this diagonal here. So you can see that this, if this is a rectangle, that will be a right angle. So just going to use Pythagoras Theorem once again. No surprises there, considering this video is about Pythagoras. So let's just call this x. Okay, well actually though, let's call it a different letter because I'm getting fed up with x. Let's use y. So we know that y squared is going to be equal to 8 squared plus 20 squared. So 8 squared is 64, 20 squared is 400, so therefore y squared is going to be equal to 464. Therefore y is going to be the square root of 464, and that gives me 21.54. 21.54. Actually, let's just leave it at 5. 21.5, and that is going to be centimeters. And you can see that it is the longest side of our right angle triangle. So I'm pretty confident that that's the right answer. Again, with rounding, it doesn't say what to round to in any of these questions. So if you have rounded slightly differently, but you've got the same answer, then that's absolutely fine. Okay, let's move on to the next 4 questions. And here we are. So have a go at answering these 4 questions. Okay, let's go through them now. So question 5, an airplane is flying from Redfield to Leek. The airplane flies 50 miles east and then 180 miles south. How far is Leek from Redville directly? So let's say that this is Redville, R, put an R there. And we are going 50 miles east. So going 50 miles east, let's say that's 50 miles, and then 180 miles south. So we're going a bit further south. So let's just say that that is 180 miles south. And now we are at Leek. So let's just label this. So that's 50 miles and this is 180 miles. And we want to work out how far it is from Leek, or to Leek from Redville. So we are looking at this distance here. Again, excuse my artistic skills here. So because we're going east and then south, this is going to be a right angle. So we can apply Pythagoras Theorem once again. So this time we're going to work out this distance. Let's call this z. So it's going to be z squared is going to be equal to 50 squared plus 180 squared. So what is 50 squared? Well, that is 2,500. I don't know what 180 squared is. Let's type that into the calculator. That gives me 32,400. So z squared is going to equal these two added together. So that's going to be 34,900. 34,900, and obviously that's not the distance. We need to take the square root. A lot of people forget to do the last step and take the square root. So the square root of 34,900, and we get 186, which is good, 0.8. 0.8. Again, it doesn't say what to round to, so I'm just going to round to one decimal place, but I am going to include my units, that is in miles. So this is my answer here, 186.8 miles. Question 6. A frame is made from wire. The frame is a trapezium. Calculate the total amount of wire needed to make the frame. So we need to calculate this distance here, the perimeter of this shape. That will correspond to the amount of wire we need. So we know 3 of the side lengths. We just need to calculate this missing side length here. Now what we can do is if we draw an imaginary horizontal line across, that actually forms a right angle triangle. Now you might think that we don't know what these side lengths are, but this side length, well, that's the same as this one at the bottom, that's 12. So this the base of our triangle is 12. Now this side length here, let me just highlight that in a different colour. So this length here in red, we can calculate that, because we know the height of our trapezium is 14 centimetres, or the sort of might be confusing there. This length is 14 centimetres, and this length here is 8 centimetres. So this is just going to be what's left over. So we just do 14 minus 8, and that will give us 6. So notice this length here, 6, plus this length of 8, will give us this length here of 14. So now we've got 2 sides of our right angle triangle. We can now calculate the hypotenuse. Let's call it A. So it's going to be A squared is equal to 6 squared plus 12 squared. So the next line, 6 squared, that's 36. 12 squared is 144. So A squared is going to be equal to these added together, which gives us 180. Therefore, A is the square root of 180. So the square root of 180 is, let's use the calculator, 13.4. 13.4, and that is in centimetres. So now we've figured out A, we can calculate the perimeter, or the total amount of wire needed. So the total amount of wire needed is going to be 14 plus 12 plus 8 plus A, which we've just worked out is 13.4. So let's see if I can do this in my head. This here is 26, plus 8 is 34, plus 13 is 47.4. 47.4. And that again is in centimetres. Okay, question 7. ABC is an isosceles triangle, which is over here. And part A is to find H. So H is the perpendicular height of our isosceles triangle. So by drawing this line in, we've actually formed a right angle triangle. So you can see here there's a right angle. We know the hypotenuse is 9. This side length here, the base of our right angle triangle, we do know, because we know the base of our isosceles triangle is 4. So this is just half of 4, because this line, this perpendicular line, just cuts this in half. So this is 2 centimetres. So now we can use Pythagoras to calculate the height. So h squared is going to be equal to our hypotenuse squared, 9 squared, subtract our base squared, so 2 squared. So again, just be really careful. A lot of people just willy-nilly add these two values together. But remember, we've got the hypotenuse, so we're going to subtract. Okay, so h squared is going to be equal to 9 squared, which is 81, subtract 2 squared, which is 4. So therefore, h squared is going to be equal to 77. So h is the square root of 77, which is 8.7. So let me round to 2 decimal places actually. 8.77. And that is in centimeters. So that is part A done. Moving on to part B, find the area of the triangle. So the area, again, is half base times height. So it's going to be a half times the base. So just be really careful now, because although we used 2 before, we're calculating the area of the isosceles triangle. So the base of our isosceles triangle is 4, not 2. So we only used 2 for the previous workings. So it's half times 4 times the height of our triangle, which we've now worked out. So the height of our triangle is 8.77. So that's why I just rounded to 2 decimal places, just so that for this part I could be a bit more accurate. So 8.77. So let's pop that into the calculator. Well, that's just going to be 2 times 8.77. And that gives me 17.54. 17.54, and my units are going to be centimeters squared. And the last one on this page, question 8, shown is an equilateral triangle. Find the area of the equilateral triangle. So the first thing to note is that all 3 side lengths are the same. So let's just write that in. So this is 10 and this is 10 here. Now we know to calculate the area of a triangle, we do half base times height. At the moment, we don't have the height. Don't be tempted to use 10 as the height. So the height is the perpendicular height. It's that height there, which is clearly not 10. So we need to work out what this height is. So again, this is going to be a right angle. So we formed a right angle triangle. We know the hypotenuse is 10. The base of our right angle triangle, well, that's going to be 5, because we know it's half of the base of our isosceles triangle. So now this is similar to the previous question. To work out the height, we're just going to do exactly the same formula we did before. So let's call this h again, because we're dealing with the height. So it's going to be h squared is going to be equal to our hypotenuse squared. So 10 squared, subtract 5 squared. So let's do the next line. H squared is going to be equal to 100 minus 25. So h squared is going to be equal to 75. Therefore, h is the square root of 75. Square root of 75. And it should be similar to the one before, because that was the square root of 77. So it should be slightly less. And it is 8.66. 8.66 centimetres. So now we've got the height, we can calculate the area. So I'm just going to do it up here, just because I've got a bit more real estate over here. So the area is going to be equal to a half base times height. So a half times the base. And again, the base is 10, not 5. A half times 10 times the height, which is, oh, it's down here, 8.66. 8.66. Let me put that into the calculator. So effectively, it's going to be 5 times 8.66. And we get 43.3. Have I done that right? Yeah, 43.3. 43.3. And our units, we can never forget our units. Remember that. A lot of people just carelessly leave them off, but we need to include them to get the full marks. And that is centimetres squared. Okay, so hopefully you got on okay with those 4 questions. I've got one last set of 4 questions for you to have a go at. Okay, so for the last time, pause the video and see if you can answer these 4 questions. So question 9, Stanley has drawn a right angle triangle. One side is 14 centimetres and another is 18 centimetres. There are 2 possible lengths for the third side. What are they? So let's just go through one example first. Let's draw our triangle in. And we know it's a right angle triangle because we've been told that in the question. Let's say this is our triangle. Let's say this side length is 14 and the hypotenuse is 18. So let's work out what this missing value is. Let's call it b. I don't think I've used b yet. So b squared, if we use Pythagoras Theorem, b squared is going to be equal to 18 squared minus 14 squared. So I'm just going to put all of this into the calculator actually. So 18 squared minus 14 squared, just because we've got enough practice now. So that gives me 128. So therefore B is the square root of 128. And that gives me 11.3 centimetres. So that's one possible option for our third side. But it says in the question there are two possible lengths. So how else can we construct this triangle? How else can we construct this triangle that will give us a different third side length? Well, what about if one of the other side lengths was 18? Let's say instead of the hypotenuse being 18, let's say this side length was 18 and this side length over here was 14. So just moving these numbers around, we'll get a different value for the third side. So the hypotenuse, we know the hypotenuse is the longest side length, so this should be bigger than 18. So for this one, let's use C. So we know that C squared can be slightly different to up here because we're finding the hypotenuse. It's going to be 18 squared. This time we're going to add on 14 squared plus 14 squared. So let's put this into the calculator. So 18 squared plus 14 squared gives me 520. Therefore C is the square root of 520, which is 22.8. 22.8 centimetres. So these here are our two answers. Question 10. ABC and BCD are right angle triangles. That's these two triangles here. We need to find the length of AB. So AB is the length at the bottom, which is marked as X. We need to find this here. Now, if we were just to use this triangle here, we wouldn't be able to calculate X because we've only got one side length. We don't know the hypotenuse. So what we're going to have to do is calculate this length first, and then we'll be able to calculate X. So we need to calculate BC, and we can do that using this triangle because this is also a right angle triangle, and we do have two side lengths. Now, just be careful because BC, in this triangle at the bottom, it's the hypotenuse. But in this triangle, it's one of the shorter side lengths. So just be careful with that. So to calculate BC, so BC squared, if we're using Pythagoras Theorem, BC squared is going to be equal to the hypotenuse squared minus this side length squared. So it's going to be 19 squared minus 13 squared. So let's just put that into the calculator. So 19 squared minus 13 squared, that gives me 192. So BC squared is equal to 192. So therefore BC is equal to the square root of 192, which is, I'm going to leave it as a third. You could write 13.86 if you wanted to round it to two decimal places, but because we're going to be using this value in the next calculation, I want it to be as accurate as possible, and to make it as accurate as possible, I'm going to leave it as a third. So I'm going to leave it as 8 root 3. Hopefully you know what this means. Okay, this is the exact value. If you're a bit unsure about thirds, I do have a whole playlist dedicated to thirds if you want to check that out as well on my channel. So this is the value of BC, the exact value of BC, and let's just write our units in. So that is in centimetres. And now we've got BC, we can calculate X. So on our diagram, let's just write in 8 root 3 here, and now we can calculate X. So we've got the hypotenuse, we've got one of the shorter side lengths, so let's calculate the other side length. So X squared is going to be equal to 8 root 3 squared, so I'm just going to put that in brackets, 8 root 3, all of that squared, minus 5 squared. So X squared is going to be equal to, let me put that into the calculator, 8 root 3 squared minus 5 squared, and that gives me 167. 167. Notice if we didn't use 8 root 3, if we used the value that we rounded to two decimal places, we wouldn't get an integer answer here. So I'm quite pleased I left it as 8 root 3. And now we can calculate X. We just need to take the square root of 167. And it doesn't say what to round to this time, so I'm just going to round it to 1 decimal place, 12.9. 12.9, and that will be in centimetres. So that is AB, that is my final answer. So question 11, a wooden flagpole is 25 foot tall. In a storm, the flagpole is broken and its top touches the ground 5 foot from the base. So this is our flagpole, it's been broken off by the storm. So this is the base of our flagpole. It was up here originally, but you can see that after it's been broken, the top of our flagpole is now going to be down here. And it says the top touches the ground 5 foot from the base. So this distance is 5. It's 5 foot from the base. Now we need to find the lengths of the segments of the flagpole. So we need to work out this length here and this length. Now at first blush, it looks like we don't have enough information. There's only one bit of information that we haven't used yet, and that is this first line. It says the wooden flagpole is 25 foot tall. So originally it was 25 foot tall, but now it's been broken off. But we can use that, and we can say that these two segments, if we were to put them back together, they would equal 25 foot. So although we don't know what they are individually, you know, it looks sort of almost half and half, but we know that when we add them together, they will equal 25 feet or foot. So if we were to label these, let's label this one A and this one B. We know that A plus B must equal 25 feet. So let's write that down. A plus B is equal to 25. And then the other thing we can say is relating to Pythagoras' theorem. So we know that A squared plus 5 squared must equal B squared, just using Pythagoras' theorem. So let's write that down. A squared plus 5 squared, well, that is equal to B squared. Now notice we've got two equations here involving A and B. So there's two unknowns and two equations, and that means that we can solve for A and B. So there are a few ways you could solve. You could just do some trial and error, put some values in for A and B to see if they work for both equations. But the problem with that is if we don't know if A and B are integers. So A could be 12.5 and B could be, well, B can't be 12.5 because that's a hypotenuse. But A could be 12 and B could be 13. A could be 11.5 and B could be 13.5. You know, there's an infinite number of combinations, really. So if it said that A and B are integers, then yes, we'd probably just do some trial and error. But I think the way I'm going to solve this is using simultaneous equations. So I've got one quadratic equation and one linear equation. So what I'm going to do is I'm going to substitute this equation into the quadratic equation. So again, this is a topic where if you don't know how to do this, I do have a video on this topic. I think I've even got a playlist, so please check that out. But what we do is we rearrange the linear equation to make one of these the subject. So I'm going to make A the subject. So if we subtract B from both sides, we get A is equal to 25 minus B. And now we can substitute this expression for A into this equation. So we know that A is equal to 25 minus B. So wherever we see an A, instead of writing A, we can write 25 minus B because these two things are exactly the same. So instead of writing A squared, I'm going to write 25 minus B and then all of that squared. Because like I said before, A and 25 minus B are exactly the same thing because they equal each other. And then plus 5 squared. And then that is going to equal B squared. So now we've got an equation that only involves B. We can solve for B. So what we've got over here, I'm just going to write this out in full. So essentially what this is 25 minus B times 25 minus B. And then plus 5 squared. That equals B squared. So now we've got some double brackets if we expand these brackets. So first of all, let's do the first terms. 25 times 25, well, that is 625. 25 times negative B, that's negative 25B. And then we've got another 25 times negative B, so that's also minus 25B. And then we've got negative B times negative B, well, that is plus B squared. And then plus 5 squared, well, 5 squared is just 25. And then that is going to equal B squared. not 6 squared. It does look a bit like a 6, but it's b squared. So now we've got a long equation here, but we can simplify this. So we've got b squared on the left and b squared on the right. So those two terms we can just cancel. And then if we look at just the numbers, we've got 625 plus 25. Well, that will give us 650. And then we've also got b terms. We've got negative 25b minus another 25b. Well, that's minus 50b. So that's everything on the left-hand side dealt with. Now on the right-hand side, well, we've just got 0. There's nothing on the right-hand side. So all of that is going to equal 0. So let's add 50b to both sides. So we're going to be left with 650 is equal to 50b. And now to get b on its own, we can just divide both sides by 50. So if we divide both sides by 50, we get 13 is equal to b. And after all of that, I could have probably done some trial and error. So b is equal to 13. And now we don't need to sort of do anything else with this, because we know that when we add them together, when we add a and b together, they must equal 25. So a must be 25 minus b, or minus 13. So a must equal 12. So b is 13 and a is 12. They do add to 25. Let's just check that that works. So we know that this is a right angle triangle. So if we were to do 5 squared plus 12 squared, that should give us 13 squared. So what's 5 squared? Well, 5 squared is 25. Plus 12 squared. Well, 12 squared is 144. What does that give us? That gives us 169. And 169 is indeed 13 squared. So we know that we've got it correct. So to answer our question, A is 12, or the height is 12, this length here is 12, and the hypotenuse is 13. And just to rub it in a bit further, I think I mentioned A being 12 and B being 13 when I went through some possible solutions earlier. But anyway, let's move on to the last question. Question 12. Benjamin has completed this question. Can you spot any mistakes? So it looks like he needs to calculate the hypotenuse of this right angle triangle. So he's written out the formula for Pythagoras' theorem correctly. A squared plus b squared equals c squared. And he's labelled his sides correctly, a, b and c. So 12 squared plus 16 squared is equal to x squared. That's correct. He squared both of these numbers correctly, because 12 squared is 144 and 16 squared is 256. And then it looks like he's added these together correctly. So everything so far is correct. And he's just swapped these two around, so that doesn't really matter. So it looks like it's the very last line where he's gone wrong. So he needs to take the square root of 400 to get x on its own, but he's just divided by 2. So it is a common mistake people make. But the square root of 400 is 20. So he's just got one too many zeros. But the square root of, let's write it down. The square root of 400 is equal to 20. So his answer should have been 20 centimetres, not 200 centimetres. So hopefully this video was useful for you, and hopefully it gave you a bit more practice with applying Pythagoras' theorem to answer some problem-solving type questions. So thanks again for watching, and hopefully I'll see you in the next video. Take care.